Well, Jonathan Schildkraut, thank you for being here. You are the head of capital markets and investor relations for Compass, and you've been in the data center industry for a long time, but really glad you're here.
I'm super excited to be here. Always a great pleasure to spend time with you and the datacenterHawk team.
Yeah, and there's people I know that know this, but you have spent time in our space on the analyst side of things. You were chief strategy officer with CyrusOne for several years. You've now been at Compass for a number of years, and so I love these conversations because you, I think, have got the real world experience of analyzing companies and seeing how they've grown over the last 10, 15, 20 years in our space, and then are a great future thinker. And we've done this before in front of cameras and not in front of cameras, just talking about the space. And so for those that are listening, this is going to be, in my opinion, probably one of the best things that we do at datacenterHawk, and just a treat. So let's dive into the market. We did this 5 years ago, and I was telling Rhett before that you made a lot of predictions, and a lot of them were correct theoretically. We undersized some of the conversations, which just speaks to the new market that we're in. But maybe let's just start there. I mean, AI is what's driving a lot of this growth today. I mean, what has surprised you about that, and kind of where are you at today with that growth?
So AI has definitely surprised us. I think everybody in terms of the scale of demand. 5 years ago when we sat down, we were really talking about the hyperscale market.
Yeah.
We're like, the hyperscale market's great, and it's going to grow this much, and that's going to require this many megawatts, and these are going to be numbers we've never seen before. And I think at the time we were talking about like 800 megawatts to a gigawatt of leasing, which we thought was great. And back then, the anecdote that I used was, cloud, hyperscale, it's everything that we could see to the horizon. But just on the other side of the horizon was AI. And we had no way of sort of measuring what AI was going to be. We used at the time some, analyst predictions for the economic value of impact from AI, and it was about the same size as the U.S. economy. And when we tried to convert the numbers into megawatts, we divided the number by 10. We said, hey, look, this number's so big, it's so obnoxious, that we're going to just divide it by 10 and say AI will be more efficient. And I think the number we said AI would produce was about 2 gigawatts of demand a year. And as you know, last year was like 7 or 8 gigawatts of leasing. Not all of that was deployed in the year, but still the scale of demand has been absolutely surprising, and the speed at which it sort of came on.
Yeah, and AI is really working itself into, this might be the wrong term, but almost the everyday life of individuals from a business perspective, from a personal perspective. I think when ChatGPT came on, that was a big wake-up call to maybe some very easy use cases for AI that the consumer might not have known before. Businesses have been trying to figure it out, but now it seems like that has only caused the hockey stick of demand to even go up further.
Oh, absolutely. And AI is so interesting. I think, ultimately it'll be part of almost every application we use. I think today we kind of talk about AI as its own sort of separate basket, but we're starting to see it make its way into your video editor on your phone, or we were just talking about Copilot with Microsoft, or it'll get integrated into search or algorithms for some of the social media. So I just think that it'll become a much bigger part of everything we do today. And I think at the data center level, obviously, the net impact is tremendous in terms of the workloads that we can go after and the scale of the workloads that we'll ultimately be able to host in our centers.
And let's talk about that, because there are different AI workloads. There's training and there's inference, and those each have different implications. They have different impacts on the space. Maybe talk about those and how you've seen that impact, where locations are where requirements are going from a location standpoint, and then also just the size of them.
Yeah, so great question, and there's like 5 great questions buried in there.
I know.
So, first let's just sort of talk about, what we're seeing really from an AI deployment perspective, and maybe even compare that to sort of traditional hyperscale deployments. Historically, a hyperscale deployment they divide a country in a region availability zones, and each availability zone would have 3 legs to the stool. These data centers would be close enough together so that latency-wise they could communicate if there was an outage, and they were far enough apart so if there was some sort of geographic disruption, all the 3 centers wouldn't go down. And so that was sort of the classical, hyperscale topology, and that really needed to be close to eyeballs, right? Because you were serving applications, and those applications had to get to people who were using them to create GDP. And so big cities, major markets tended to be able to draw that type of demand. And now what we're seeing, and the numbers seem to get bigger every single day, but 200, 300, 400 megawatt training AI nodes. And the big difference here is that these are much less latency sensitive, and so they're also less location sensitive. And so we are seeing them pop up in areas that are further away from that sort of core density of eyeballs. But the total scale of where AI is today and where it could go, we think will vastly overshadow how much was ended up in traditional hyperscale architectures. Just before we threw the mic on, we were talking about some numbers, and some numbers that I find particularly compelling are the Nvidia numbers. So Nvidia last year reported $47.5 billion of GPU chips sold to the data center industry. It was $18.4 billion in the quarter. For the year, it grew 200%. For the quarter, it grew 400%. So we're clearly seeing a big acceleration. And speaking to our customers and sort of doing our own work, what we've realized is you can get about $50 million of GPU chips into a megawatt's worth of capacity. And so if we translate those numbers, what it says is that last year, Nvidia sold about a gigawatt's worth of GPU chips, and about 400 of that, 400 megawatts worth, was in the final quarter of the year. And say Nvidia's 75% of the GPU market, it's, 1.25 gigawatts of demand on the full year and maybe 500 for the fourth quarter. And what we know is that in terms of what got installed globally last year, it was probably in the 5 to 6 gigawatts range. We know leasing was much higher,
Sure.
And we could talk about some of those dynamics later. But we know that from an installed basis, that's the right number, which tells you that demand was crazy anyway last year. And it tells you that, right now, the AI, the GPU chips are only representing maybe 15%, maybe 20% of global demand. And so what we're seeing is a hockey stick of demand. And we know that the rate of growth of the GPU chip sales is so great that the demand will flow through to the data center space. So I think in totality, we're talking about a much bigger scale than sort of we've ever seen before. And the numbers that I see in terms of total data center demand over the next 5-6 years look like somewhere in the 60 to 70 gigawatt range, which is an absolutely massive number. Now, to the second part of your question, where do these locations, where do they end up? And, this is one of my favorite topics, because I think that when we talk to investors and we talk to folks who are maybe not in the data center world day to day, they look at some of the new locations, whether it's, Council Bluffs or Des Moines, Iowa, or Lincoln, Nebraska, or Cheyenne, Wyoming, and they say, oh man, they're putting these things in the middle of nowhere. It just doesn't even matter anymore. And I think that if you think about real estate from a traditional perspective, which is the most important factor is location, then you're right. It looks like the middle of nowhere when you stare at the US map. But data centers aren't just about physical location. They're also about logical location or virtual location. That is, where do you live on the internet? Mm-hmm. And so when we look at that same US map, instead of from a sort of physical topology perspective, but from a virtual topology perspective, that is, where are the major fiber lines, where are the highways of the internet, what you find is that there is a major highway that runs right across that 41st parallel. Just a few years ago, one of the engineers from Microsoft put up a really good thought piece on LinkedIn about this very thing. And basically what he explained was that when they were building out the major fiber networks in the United States, They were looking for a place to put the biggest east-west route. And they realized they could go to 10,000 different farmers and negotiate a lease for a tiny piece of land, or they could go to the Union Pacific Railroad and instead get an easement that would reach all the way from Council Bluffs, Iowa to Sacramento, right across that 41st parallel. And what else sits there? It's not only Council Bluffs, but it's Lincoln, Nebraska, it's Cheyenne, it's Salt Lake City, it's Reno, Sacramento. All of them are in close proximity to that major highway. And so when we look at that map and we say, oh, you're in the middle of nowhere, the truth is, from a virtual topology perspective, they're actually on beachfront property. So what we think is that these big training nodes will end up, on those major highways, those major fiber highways, where there's still power to be had, because that seems to be the big constraint these days, the long pole in the tent, if you will.
And how is the scale change impacting things like design? So you obviously sit with one of the major data center operators globally, and thinking through how do you change the design to meet the new type of scale that you need to?
Yeah, well, I think at Compass, we try to think about our buildings as forever buildings. And what we've really done is we've made sort of the building, the floor space, the data halls, we've made that sort of the same in every single building, no matter what. And that doesn't ever have to change. For us, we put major components, the mechanical plants, the electrical plant on the outside. And so what we think is, over time, when we need new capabilities, we'll just sort of pull out the plant on the outside and plug in some new plant. But really what we are seeing is obviously a major increase in the density of power and per cabinet, if you will. And that has different requirements from a cooling perspective. Today I think that with, an H100 or an H200, you probably get about 40, 50 kW per cabinet. And with the Grace Hopper chip, it's supposed to be about 40% more efficient. So, that'll knock it down to maybe mid-20s in terms of kilowatts per cabinet. And then the next generation will be much more power consuming, but more powerful. And then you'll see another generation that's more power efficient. It's sort of like flat panel televisions, right? So the first flat panel television was a plasma, right? It was super cool. You got it home, you put it on the wall, the picture was amazing. And if you went near it after about 40 minutes, you could feel the heat popping off. And the energy consumption was off the roof. But behind that was, LCD and all these other technologies, OLED. And really what we see is a pattern, which is an oscillation where technologies come out and they're most focused on sort of performance first and efficiency after. Performance up, efficiency down. Performance up, efficiency down. And I think we'll see that same sort of pattern as it applies to GPU chips and then ultimately into what gets deployed inside the data center. For Compass, we could probably cool about 70 kilowatts per cabinet using our air-cooled systems. And, we're waterless, so we use a refrigerant. But we are working on and have a hybrid solution which allows us to use water or air where we can get to much, much higher densities. And so I would expect that other folks follow down the same path and be creative. And when you look around the industry, there are actually a lot of really creative leaders out there. Right down here in Dallas, we've got Andrew Schaap, who does, some really great things with Aligned, but there are many other players out there as well.
To the efficiency, as the efficiency changes in the chips, and you can, basically do more with less, what do you say to the listener or someone that says, well, if that's the case, once it just gets, super efficient, won't the demand come down? Like, will there be need for all the land that's being purchased and all, like, to that person, because those questions are out there. Yeah. What would you say to that, person?
Oh, I have so many answers to that person. Listen, when I got to law school, I got a 500 megabyte hard drive. And I was like, I will never, ever use this whole thing. It's enormous. Yeah. And now I carry, hundreds of times that in my pocket on my phone. So I just think that, we get more and then we use more. We figure out ways to increase productivity, increase compute power, and then we figure out ways to use that power. So, personally, I'm not very concerned about that. But I'd also say, there's another cycle here, which is, a lot of the AI training is really based on data. And I think if you go back to the time that we first talked, we talked a little bit about data gravity and what data gravity was. But ultimately, the idea was that data is very hard to move, right? A single cabinet, which is a refrigerator-sized space, can hold 6 to 7 petabytes of data. if I push that over a 10 gig wavelength, whether it's across town or across the country, it's going to take me 60 days. If I've got a 100 gig wavelength, it'll take me 6 days. That's for a single cabinet. It is cheaper and faster to hire a couple of folks to grab the cabinet, throw it in the back of a truck, and drive it from New York to San Francisco than it is to try to push it across the internet. And so what happens is over time, you can't move that data around. So it has gravity. And so ultimately, you got to bring the compute to the data and not the data to the compute. Now, why is that important in this context? And simply because in 5 years' time, all of the data that's on the planet today will be less than 5% of the data on the planet from then. And people say, oh, no, once you've trained the model, it's over. It's good. It's got all the data it needs. Do personal habits change? Do personal preferences change? Technology changes? Data is always changing, and the relevance of the data is always changing. And so the most important data is the newest data, and that newest data is 2x last year's data. And so I don't think that we're going to see a time where you're going to need substantially less capacity in any place because of the scale of the data being produced, the pace at which that data changes, and the inability to shift it around the country. So I think those who are out there winning some of these large AI training nodes are in an excellent position.
Most of the demand that we've seen AI-wise has landed in the U.S., and there's reasons for that, and we can talk about some of them. But, Compass has certainly a U.S. and Canadian footprint, has global locations as well. But maybe just give your thoughts on how the maybe scale translates to other areas of the world. Is that easy to put that demand over there? Is it hard? And it's been interesting to watch the capital expense, because I think several years ago you were seeing almost like a decrease in capital expense in the U.S. and then that money being spent to Europe, APAC, Latin America, and now a lot of that money's come back to the U.S. to solve some of these challenges. So what are your thoughts on the global view of AI and how it plays out over the next several years?
All right, so there are going to be two pieces to my answer. One piece is going to be about training nodes, and the other piece is going to be about inference.
Okay.
And training is, making the AI smart, creating rules, and inference is about sort of taking that knowledge and those rules, incorporating into applications or other things so that it can be used closer to the user. So from a training node perspective, which is what I think we see these giant campuses, in the US, they're 300 megawatts and getting larger every day. As I look around the rest of the world, I think it's going to be very difficult to replicate. Already in the US, we're stressing the power networks, the utility grid. But when you look, say, at Europe, Europe is going to have real challenges. First of all, they don't have access to power the way that we have in the US. But also the availability of land is also much less. And then I'd throw in GDPR, which simply says that data can't be moved around from one country to another. So, for Compass, we look at the world and we go out and try to acquire land. And again, we think of ourselves as the campus sort of company. It's a minimum of 200 megawatt campuses in the US. I think as we look into Europe and other places in the world, it maybe be half of that, like a 100 megawatt size campus. And I think the idea simply is that the United States, from a physical geography and population perspective, is probably, on par, give or take, with Western Europe. And so in Western Europe, you can't move that data around. So each country is going to have sort of its own training. And so those training nodes will be much smaller relative to what they are in the US. But I do think there'll be a similarity in that they will move away from the major sort of GDP centers. I don't think you're going to host an AI training node in London. I don't think you're going to host one in Frankfurt. But there are areas in the UK and there are areas in Germany where if you were willing to push out and there's a fiber line, you're capable of putting it there. So from a training perspective, I'd expect it to sort of look like a smaller version of the US. The scale just doesn't need to be as big. On the inference side, this is sort of the million, billion, trillion dollar question in terms of what comes next. And when we were at PTC together, and I'm still got that analyst hat on, I'm trying to gather everybody's opinions and try to figure out what we're going to see. I think people said anywhere from 2 to 10x. That is, inference from a total demand perspective will be 2 to 10 times as big. Now it's such a giant range, granted, but still it's massive, massive scale. And the other question was, where does it land? And a lot of people will tell you that it's going to be really close to the users. You can't prevent pedestrian accidents rather in Las Vegas if the AI inference is far away, because you won't be able to react fast enough. And I certainly believe that there'll be use cases like that. But our belief is that AI will be incorporated into the applications that we use every day. At work, we talked about Copilot just a minute ago, whether it's Google search or social media. And so AI will just sort of take all of the applications and make them more powerful. And if that's the case, then most of that inference will end up right next to where the applications live and inside the traditional hyperscale architectures. And today, even, we're seeing the hyperscale sort of availability zone explode in scale. What was maybe a 100 megawatt region before availability zone might be 500 megawatts or more. And so what we're playing for at Compass is we're playing to get sort of two pieces of that critical infrastructure. We want the AI training node for sure, but we also want one of the critical legs of that hyperscale architecture, because we believe that will continue to grow meaningfully over time. And I think in Europe, again, you're going to see it replicate, but just on a smaller scale. There is one other thing I wanted to touch base on, which you brought up in terms of like how much capital in the US, capital internationally, but capital in general. Again, if it's 60, 70 gigawatts of demand over the next 5 years, okay, if that's the right number, and I think it probably is, what we're talking about is, $700 billion, $600 billion of capital, $120 billion to $140 billion of capital on average. This industry is not prepared for that type of capital need. And so I think capital, and now as a capital markets person, will become a critical part of the ability to deliver. And as we've come through, this quarter's earnings, you've already seen a lot of the major hyperscalers and AI investors talk about much higher CapEx in the coming year and years than they've had over the last few. So
I'm glad you brought up the capital thing. I wrote down to ask you, what's the most important thing a data center investor needs to know right now from your standpoint? You talk to a lot of people that are probably deep into the space from an investment standpoint, and maybe those that are trying to get in it for the first time.
Look,
what do they need to know?
Well, this is just an incredible time. In a lot of ways, the fact that power is so hard to get and to secure and at the scale that's necessary, it's increased the customer's reliance on outsourcing. We used to say 75% of hyperscale demand was self-perform. And I think that, if they could, and it's not a technical capability or intelligence capability, it's just a scale capability. If they could, they'd stick to that. And as recently as a few years ago, it was moving towards 50-50. And at the Cowen conference in August, there was a panel, and the panel said it was about 80-20 right now, 80% outsourced, 20% insourced. And further, because, again, the hyperscalers, these AI companies, they need more help, they were willing to lease from people who had earned their trust instead of, hey, I have to walk the floor, or maybe 6 or 12 months in advance, 3-4 years out and longer. And so, that also adds in a very positive way, but it doesn't solve the energy problem. And then when it comes down to the energy problem, energy lives, power lives on 3 levels, right? There's generation, so how much do we create? There's transmission, how do we get it around the highways? And then there's distribution, which is sort of the local roads. And we obviously have a generation problem, particularly in the light of this transition towards more renewable, more green energy. There are challenges in terms of just overall generation. And then, I think has been talked about pretty widely, even by Chris Crosby, our CEO, the transmission network needs a major uphaul so that we can get that power from where it is today to where it needs to be. I think distribution tends to be a little bit more sort of consistent in terms of its abilities. But we have power problems at multiple levels, is my point. And so I think what we're seeing and what we'll continue to see is people trying to generate creative solutions here. A couple of years back, I was a very big proponent of nuclear power as the long-term solution. I am still a very big proponent of nuclear power as a long-term solution. Maybe not in the traditional form of nuclear power. There was that great deal with Cumulus and Amazon up in Pennsylvania. And, I think that is a very big nuclear power plant. You're co-locating right next to it. There's a lot of benefits there. But I think more than it being, hey, this is what it's going to look like architecturally, I think it's the acceptance piece that I find so incredibly creative. Like, we see Amazon, I think I've read reports about Microsoft exploring this too, and others saying, hey, you know what, nuclear's not off the table. And what we're seeing from a technology perspective is, SMR, so small modular reactors, and microreactors, which are maybe, 300 megawatts to up to a gig, sort of that range, starting to come to market. Now, I'm not saying you can go out and buy it and drop it in your backyard. What I'm saying is that the folks who have the capability are starting to come out and have meaningful discussions with the data center industry. And so over the next, call it 3 to 7 years, I would expect a number of those deployments to make their way into the market. It takes a while for bringing it to the market, but it's a very different thing. And in a lot of ways, what we're seeing with utility reminds me of what we saw with data centers, which is, utility is the classic example of, distributed, centralized, right? Oh, everybody had to have their own power plant in the 1800s, right? It's like in early 1900s, you generated power at the farm, you generated power at the factory. And then they discovered that, hey, if we generate all this together, we could get much better efficiencies, and then we just distributed it out. And today, I think we're sort of seeing this push again towards a more distributed power production environment. On the data center side, right, we had mainframes, everything was centered, and you had your dumb terminal, and that all happened over a LAN, so you couldn't go too far with that. And then we had the client server PC era come in, and all of a sudden we got widely distributed, and so the compute and the apps and the storage all got pushed out to the edge, and then cloud came in, and all of a sudden we centralized again, and now we bring it all and we push just a little bit out. And so it's really interesting to see the parallels between the utility, the power part of what we do and what we need, and also sort of the compute part of what's happening. I think there's a lot of parallel there.
Will there ever be a time that we will be in a power environment like it was 4 or 5 years ago, where if you needed 36, 72, 100 megawatts, you could get that in 12, 18, 24 months? I mean, and do you think we can return to a world like that?
So my gut instinct is it will get better, but it will never get that good again.
Yep.
And there are places in the United States and around the globe where maybe you find one, and you're lucky, right? I mean, if you've got one, give it to me because I'll go develop it. But they're harder and harder to find where you can really get power in a short period of time. And it's going to take a while because a lot of this is a generation issue. And even when there's generation, there's transmission issues. And even when there's transmission, you have to then create a substation to step down those high density power lines into some sort of medium voltage that can be consumed at the data center level. And, when I was at Cyrus, part of my team was site selection. I spent 2 years working on the development team under AJ Byers at Compass, and what I'll tell you is that when you go out to build a substation, the transformers are now a couple of years away, and so
the components of
building it, and I'm not seeing that part of the supply chain improve. If anything, that part of the supply chain seems to be extending further and further. And when, for Compass, one of the things that we do is standardize prototypes. We couple our supply chain with our prototype, so we get a certain amount of capacity rolling off the line dedicated to us for our prototype. And we use the same equipment everywhere, whether it's Montreal or Arizona. And so we could really have almost down to the megawatt a very good insight into how much we can deliver at any given time. Now, if we wanted to try to lift that and apply it to building substations, it's not plausible. And the reason it is because we don't get to choose what the substation looks like. The utility chooses what they want from a substation design, and they will choose the type of equipment they want. So we couldn't even pre-order transformers because they wouldn't be fungible amongst locations. You might get one and be like, oh yeah, we'll accept this, but you And I'd say the probability would be against that. I think the probability would be in favor of you having to buy different pieces of equipment for every substation around the country. So I think it's going to continue to be a problem over the next several years. You know, as far as I can see out into the future, I think it's a challenge. But in a lot of ways, I think data centers will take on more responsibilities. You know, we need to be partners with the utility, with the community in terms of managing power consumption. And whether it's, hey, I agree to step onto my backup generators for 100 or 150 hours a year so that you can manage load to critical places like hospitals and, you know, homes and things like that during those, you know, really critical hours, I think data centers will become part of the solution and less viewed as part of the problem.
So not that 60 to 70 gigawatts isn't exciting and something to get, you know, excited about, but what gets you most, you know, excited about our space over the next 5-10 years, you know, from your standpoint?
So there are a bunch of things, you know, David. We've been fortunate enough to be in this space a long time. I wrote my first research report on a data center in 2003. Mm-hmm. I was part of the team, first analyst group to relaunch on the data center sector. It was on Equinix, and the stock was in the 20s. You know, so whoever invested, even over a 15, 20-year period from then to now, still made boatloads of money. But the point is that we've been long enough in this industry to sort of see it go through cycles. And at least 2 times and probably 3 times in this 21-year journey, I've been like, we're near the end. Mm-hmm. This is it. And, you know, whether it was OpenIX and what that was going to do to the interconnection system or, you know, the big short reports that came out in like 2011, or even in 2020 when we were seeing, you know, competition and prices and sort of unbridled supply hit the market. All those times, you know, you question where you are. And what I feel is, as that longtime observer, and I think you probably feel the same way, I hope you do, is that the longer we wait, the earlier it gets. And so what really excites me is, you know, what I really can't see. You know, when we got together 5 years ago, I used cloud's everything to the horizon, AI's on the other side of the horizon. Today, I would use sort of a different analogy, a different metaphor, which is this generative AI demand. It's a wave, and it's coming at us, and it's ginormous, right? It's coming at us, and with any sort of wave, you know, that comes in like that, the real power is behind what you can see, right? There's a wall of water behind there. And I think that wall of water, whether it's, you know, further investment into what we're doing on a generative perspective, or it's the inference piece, which, you know, we really don't know how big that'll be, that's what excites me. And so I see massive demand. I see us early in this game. I don't know every application that'll be used. I'm excited to see how that plays out. I'm excited to take advantage of it. But also, anytime that happens in an industry, people who are creative, who really understand the fundamentals, they have opportunity. And, you know, Compass, because of the way we design our buildings and our approach to sort of last forever, we want to build 100-year buildings, I'm excited in the seat that I'm in, because I think that as all of this comes, and we all need to pivot, because we will need to pivot and learn and move, that I'm going to be part of that evolution, and Compass is going to be a meaningful part of it as well. Yeah, well, there's so much opportunity in the space. You use that word, which is really good, and we need to do this faster than 5 years next time. But hey, thank you so much. Your comments are always fascinating, very thought-provoking. I think if people are like listening to this, if you like, go listen to our podcast 5 years ago, because it will actually provide some really interesting perspective on the comments that Jonathan made today and where the industry is. But hey, thank you again. Look forward to doing this again soon. Hey, it's a pleasure. Really appreciate you bringing me in.